myself, my name is Apostolos, and I'm representing Odyssey. Odyssey is a premier cybersecurity provider in the broader region of Europe and Middle East, and among other countries, but our main focus is there. So we provide a whole range of consulting and technology solutions and services for the cybersecurity defense, as we say. The reason for this webinar today is for us to be able to bring you, our customers and partners, in contact with Keysight. Keysight is a partner of ours that is specializing in what we call visibility in your network and cybersecurity, of course. So in the course of today's webinar, our esteemed colleague from Keysight, John Adams, will present a few interesting solutions that you'll be able to understand the relevance these days, especially with the coronavirus still at large in some countries, hopefully not that much in Greece. And since the cybersecurity arena, as we see it, has changed, and now, VPN, remote access, openness of the perimeter everywhere has posed new threats, and we need to understand and mitigate them. We believe that Keysight has the solutions to be able to do so. I hope you will enjoy the call today and the webinar. And of course, Odyssey and Keysight are at your disposal after the finish of this webinar. And I would like to pass the floor to John Adams. John, the floor is yours. And thank you for participating today in this webinar.
So thank you very much, Apostolos. I might ask on you for a little verify as I change screens between the presentations and the browser while we're going through the demo. So if you wouldn't mind, maybe just jump back in and give me a good okay when we get started or when we're changing. So hello, everyone. My name is John Adams. I operate as the Channel Solutions Engineer, one of the two Channel Solutions Engineers for the EMEA area for Keysight NSS. Today, we're going to be speaking a lot about how we're going to help you automate a lot of your network test and security verification and validation, and help you prepare yourself to combat the oncoming threats as they come out with some of the most resilient threat intelligence and testing, let's say, heritage that's in the market right now. So at first, we're going to focus on the performance and the edge visibility through active network monitoring with Hawkeye. This is very useful when it comes to testing, say, your VPN to verify how voice calls might be completed between locations, between branch offices and your primary data centers, wherever you might have SIP proxies or things like that. It could also be used to test and validate Wi-Fi networks. This could be the Wi-Fi network of a hotel, or it could be the Wi-Fi network that's hosting a camera that's running down a football field that's watching football players at the same time because they need to fly around now. In any case, we have a lot of ways of generating data that's very easy and convenient for the technicians and the engineers, and mostly giving these technicians now 1,000 hands to operate in these environments, turning your engineers into super engineers at the end of the day. So before we get started into the product, I want to give a little bit of history about Ixia and into Keysight, and maybe this will give a little more insight about the history and which you can believe, or let's say the technology you can believe in that comes with this company and these products. So first, we're going to start with Ixia, starting as a layer 2 through 7 testing company founded in 1997 in the United States. So they focused on load protocol and capacity. We wanted to take your firewall or your router or your switch, and we're going to put the biggest box we can on both ends of it, and we're going to test it to see how much data it can get through it. Can it follow all the routing protocols necessary at the highest loads, and ensure at any moment in time, at any load, that that box will give you the performance you're looking for. So after becoming the market leader in this area, Ixia decided to branch into the visibility market, acquiring NetOptics and Anui. I actually came in with a NetOptics acquisition. So during this time, they get into network packet brokers, taps, bypasses, and a lot of visibility inline security concepts. From there, the technology gets brought together into a Vision 1, a turnkey network packet broker, and we see the maturity of other products such as HawkEye and CloudLens. HawkEye being an active monitoring solution, and CloudLens being a virtual visibility solution. So HawkEye is an active monitoring solution, meaning that it's going to use the technology of its predecessors that it originated with, but we're going to now change this in the way that it's the most correct type of testing for the production environment, so we can know exactly what's going on in our production networks. So with all this nice testing technology, Keysight comes by and acquires Ixia in 2017. Keysight, just to speak a little bit about them, is the original Hewlett-Packard company. So this is the electronic test and measurement company, the ones who built the oscilloscopes, the ones who built the spectrum analyzers. Whenever they decided to build PCs as well, this company split. One went into Agilent. That's actually the electronic business, the test business, while the rest of the business, the PC making business, went in another direction, and that was HP. So Agilent went on for a good amount of time before they started again to acquire more businesses as they grew in market and size, and they got into life sciences. Now, after it came once again to another point, they didn't want to, or let's say this electronic test area of the business didn't want to concern itself so much with these other markets. They wanted to get back just on network tests, and they saw a new market to kind of rise up out of the ashes, and that was the 5G. So 5G is coming in, and Keysight is once again a spin-off of this original electronic test and measurement business to focus on how we're going to test and validate 5G as we start to build these antennas and deploy them in our near future. So what's convenient about Ixia is that we knew how to generate a lot of interesting traffic that ranged from the data center to the mobile network, so we could generate a virtually evolved packet core and help them emulate the entire segment of the network from layer 1 through layer 7, and now we can completely test start to end the 5G environment. But bringing it back to the Ixia story, and as you see here, there's going to be a lot of chassis and devices that are positioned here and there. The big picture here, we have devices that test just about everything that reside on your network. So with that, you'll see HawkEye is gently distributed across this entire network, and that's generally the point. While you see these chassis are generally very big devices that are meant to pump out a lot of data, a Hawkeye endpoint is meant to be a very lightweight software or hardware endpoint that'll allow you to generate a little bit of data to verify the configuration of your network. So HawkEye is a single pane of glass controller for all of these endpoints. And these endpoints could be things resembling a packet broker. They could be a Raspberry Pi that's been rebranded with extra gear to get better Wi-Fi testing. Or you could have something like an IX Pro, which sits as more, let's say, a tool for the blind spots, something you can sit in line with a very, very light amount of configuration to gain a little bit of information about utilization, and also create a little bit of testing from a location that might be very remote. I'll go much more into detail about how that is positioned and when we go more into the hardware. So once again, we have the Vision Edge 1S. It's going to be a packet broker that's going to allow you to generate net flow data. It also acts as a positioning point for certain third-party support. So we do have integrations for, say, security onion. You could, like, for example, have your packet broker collecting all this information, helping you to send the traffic where it needs to go, and then also hosting a security platform right on that very same box. From there, the XR Pi is a Hawkeye endpoint for Wi-Fi testing. This will enable you to validate how would the in-user equipment act inside my Wi-Fi environment. This could be inside the office, once again inside the hotel. This could be sitting on the camera that's flying down the football field. IX Probe, once again, it's another Hawkeye endpoint focused mostly on inline management, meaning it's going to allow traffic to come in and pass right through. It's going to have a fail-safe, let's say, it has a fail-safe operation. For example, if the power were to be removed, it'll close the link. This is technology that's been used inside of our bypass products for decades now. And then lastly, we'll have software endpoints, which allow you to deploy endpoints, mostly anything that has an operating system. And so this is very easy. You can actually put them on your phones. You can put them on your Windows PCs in, virtual box VMs, anywhere that you can allow yourself or wish to do some testing. I'm not going to focus too much on these check marks. The biggest thing to understand is that there will be certain devices that will have certain capabilities of testing that others won't. Say, for example, the software endpoints will not be able to do such as real service testings. What is a real service testing? Well, this would be a test for me to verify how is my let's say, endpoint communicating with such as Microsoft 365 suite. So such as my mail or my docs or my OneDrive or things like that. From there, we're going to need to have the XR Pi to conduct the Wi-Fi testing, or you can do certain amount of Wi-Fi testing from the software. As you see, they'll both be checked off here, but there'll be certain, let's say, Wi-Fi oriented information, such as, channels that'll be being used, decibels and power levels and things like that, that we needed to have the extra hardware inside to get to. So synthetic monitoring, control the variables, reduce the algebra. To me, this is a very important statement that goes with all of this. Whenever it comes to troubleshooting an environment, inside networking, it can get very interesting because there's so many different things that can go wrong. It could be time, it could be the STP configuration, it could be an application load balancer. There's so many, it could be the application itself. So with all these variations of things that could go wrong, we need to start to remove certain components to make that math a little bit easier so we can start to get through the logic of what's going on. So Hawkeye, yes, it's going to enable you to do testing, but don't think about it. It's just going to do some initial testing so that you know things are right. It's a testing platform that's going to be testing continuously. So with that, what we can test or how we're going to test is between endpoints. So as you see here at the top, we might have a XR Pi or a IX Probe that might go to the data center where we have a Edge 1S network packet broker. In this, I can measure the, let's say, this first leg between my branch to my data center, and then also have software endpoints, say, in my public cloud infrastructures. So I could test also, let's say, web applications that will be residing in this public infrastructure in a continuous manner, meaning I don't need to have an engineer to go and, go to that website physically, verify that it's coming up, and go through each page to see how it's coming up. So as you see here on the bottom, we're going to have different types of traffic we're going to be testing with. We are not going to be testing with the application or who I should be talking to at the end. Why is that? We want to remove that variable. What I want to understand at this point in time is, how does VoIP traffic traverse my network in its present configuration? Nothing else. I don't want to have an issue with the phone. I don't want to have an issue with the host. I don't want to have an issue with the application. I need to understand, if I send this traffic, specifically this traffic across this network, what will happen? So I would sometimes maybe deploy a endpoint on an adjacent server next to my web application server inside the same network, just to verify configuration all to that point before I would go into real service testing. So in real service testing, this is going to be one-arm testing, and we're going to test from an endpoint to the actual application I need to communicate with. So from here, we're going to focus on most of the practical needs of a business. So a lot of it's going to be oriented to Microsoft 365 and testing your mail services, chat services, OneDrive services, things like that. But with that, we can do HTTP calls and even custom URL calls to your own web servers. Meaning that after you've conducted the first testing between the two endpoints to say, well, I know HTTPS traffic will traverse here with this latency, it'll pull pages, quite efficiently. I shouldn't have this issue. I'll move into this point now, and now we'll test your web server directly. We'll show you exactly how much time it takes to pull down each page, and we'll do it every 5 minutes if you require it. And at the point of that, meaning like once you get this configuration state in place, you know your configuration's right, what we're trying to prepare you for is the changes that will happen on a day-to-day basis. And that might be, business process changes, but also say if you're a bank and you're hosting a customer web portal with, they have an app and the browser so that they can get to their accounts, and you're making changes on this on a daily basis, you might want to have tests that go to every single page to make sure they always load quickly, and that your customers are getting the best service they desire. And what's convenient about this, no one's going to need to press a key to get this done. So once you start these tests, they're going forever. The operational team can have these tests going while the development team is just updating and updating and updating. And then once something goes wrong, you'll get a report about it. So moving forward with it, there's going to be a few extra nice features to give you a little bit more information about the environment. So with network path discovery, we're going to give you a graphical representation of how that traffic will pass through the network to show you, well, is your load balancing criteria working? Is the paths that you're trying to use actually being used the most? So we're going to use these thick or thin lines and these color codes to give you a little bit of information about how that traffic is passing. This could be very useful for testing Wi-Fi networks or ensuring how traffic is passed between branches, the data centers to branches when you have applications that need to communicate with each other. So performance and analytics, that's what it all comes down to. We were doing all this testing to give you information to allow the engineer to get done with his work as quickly as possible. I can't remember where the information comes from. It was one of those nice Gartner reports. I think the mean time to resolution actually comes in at about 80% just spent on troubleshooting to try and understand and define the problem. So if we can have tests that's being done on an everyday basis, every 5 minutes, every hour, done in the very most lightest way possible, it should act just like a single phone call. You should never your network should never crash on a single phone call, right? So this is something you can have done to understand, well, at 9 o'clock, we saw a little bit of extra delay, and then it goes back down, and then maybe at 12, we see a lot of delay. And you can start to think about this. Well, what is happening during this time of day that we would have these issues? Well, it could be company calls. It could be you had a corporate WebEx, and you had hundreds of people on, and it flooded the network. And at that time, yes, you did have certain delay. But on the other side of that, going back to cybersecurity, it could be when the botnet starts talking. Something to think about. And this is something to consider whenever you start to look at, performance and security. They need to be looked at holistically if you really want to get the job done at the end of the day. Everything is important. So going back to these reports, we're going to give you a lot of nice graphical data to make it easy to understand how things are being observed across days, weeks, months, so that you can understand where those variations came in. You can have these reports generated for you on Monday morning or Friday morning when you have your first morning meeting, or at the end of the week to tell everybody, hey, the network's still safe and it's all validated. You can put it away. There's no concern. So with one of the most recent updates, we've included a machine learning concept in the idea of thresholds and alarm thresholds that would be related to specific tests, excuse me. So the idea is that every network is different, just like every person. Every network's going to have its little tweaks, certain configuration differences that are going to create a different result. And it can get difficult in very, very large operations to try and understand how every little path may react differently and adjust those thresholds and criterias to the, the most correct way. So you're not, going through alarm death, and then you end up silencing the alarms, and then you don't even look at the alarms, and they just keep coming anyways. And there could be actually some serious threats. So we've included now in a machine learning process that will look over an interval of time, and you will define, okay, we're going to start learning now, and this is what's going to be considered good. And so from here, as you see with this red line that kind of dictate our mean values going across, up until about 2 a.m. on 17th of October, we have that certain spikes. Also over at 8 o'clock. What these would be are your outliers. It's saying, well, in this particular, and I think this is a jitter millisecond trend graph, across this time, at these specific times, while I was conducting these tests, we saw these variations. And that's what we're going to alert you now on, is not this pre-configured static idea threshold, but this variation that was a real change inside of your network. So just a little more graphical information. You can see, I'll be demoing this so you can see a little bit more in action, where I'm having my local PC here testing with a lab in Bucharest. So just going into a little bit the use cases, so you can start to fit, where in your mind, how could you utilize this outside of making your engineers super engineers. Is possibly the best thing for me, coming from I come from Military Network Operations Center, troubleshooting satellite communications, and it is chaotic. And I wish, oh man, I wish we would have had this type of software available to us at that time. But when it comes to where you can use this, you can use it generally about everywhere. And one thing here we're looking at is a larger scale concept of highly distributed architectures, internet transport. I have some type of application that's going to reside on data centers that could also reside in various data centers across the entire planet. It needs to be able to spin up, do some testing when it's available, come back down. It needs to be easy to test this entire environment, because there's so many endpoints, and the topology is so big, and I don't have the engineer or the team to send everyone to each location, or I don't even own the infrastructure. So I'm gonna need to put some endpoints into all these various locations that allow me to do all the various testing to ensure completely that my path from A to B, B to C, C to D, or A to D, in any case, will be acceptable for my network, and will give me the best user experience at the end of the day. So with that, we can also get into the Wi-Fi testing. As you see here, the channel information, some of the decibel information you see to the right. This is why we need to have the XRPi, so we can get into this data and extract it for your reporting information. So again, you would use this to deploy various XRPis all over the stadium, the hotel, and start testing how are my users' experience YouTube video coming directly to them, or a voice call like as they were sitting at the field. The IX Pro, as I said before, it's going to be a situation of I need to get eyes into a network I would not normally have eyes in, and allow me to do this type of testing. So in this slide at the bottom, you're going to see some graphics. So you see ISP owned, and you'll see client owned. So from the concept of the ISP owned, we're talking about I'm an internet service provider, and I have an SLA with my client to give them a certain amount of speed, and my client calls and says, hey, we're not getting what we expect. Something is wrong. At a certain point in time, the ISP didn't have too much equipment on the inside of the client's data center to allow him to understand, well, how much traffic am I able to get there? Are the utilization somewhat right? And even with that, not an endpoint that I could validate how much voice or VoIP, or even doing speed tests between these two locations was even capable. So once again, this is going to be a device that's going to put directly in line of your equipment if you are the ISP, and your client. The client would not be able to access this device. It'll be controlled with an access list only the ISP could get to. And thus, I can now do testing from my if I'm the ISP who has Hawkeye, I can test internally to verify from point to point, going through my entire network. I then go to my edge of my network and I test to the edge of your network. And if I can see the correct speeds and the lack of loss that you're experiencing, this is where it could come into the place. Well, do you have cables hanging out of the ceiling in your network room? And this could also be the case. People don't really know what the problem is in a lot of cases. They just start complaining. I have some type of problem. It has to be the network, or it has to be this. Not a lot of people really know what's happening. There's like I said before, there's so many issues that could be at hand. It could be a faulty cable that's causing these types of things. So we need to do as best we can to create science experiments to validate it to ourselves. This is how I know, because I know it's passing this traffic. I can validate it with this information. I have no concern that I have trustable information here. So little diagram to further explain that. Provider cloud, customer network, going through the carriers into having this IX probe that would sit on the edge, because I would not have visibility into that customer's environment. Once it gets past that edge router, border gateway router, and goes into their core, you're out. So this will allow this would allow the ISP in this case, and this could be, you'd have to be creative in your own aspect. Where is a place that you don't have visibility into, you don't have the ability to test into, that you would like to? That's what you're trying to find here. And this is something you would give to a typical manager that has no IT skill. Hey, just go find your modem, plug it in, and you're done. That's the type of setup you would do here. From there, the IT in the back would take care of everything. Just a quick little note, we have really nice Armon counters available for your IX probe. This was a big requirement for a lot of the internet service providers in the US, and which made this product quite successful. Before it was just strictly as an SNMP tool. We later upgraded it with the HawkEye platform, so we can get more than just these statistics, but give you a testable endpoint for these situations. So real quickly, if you're going to have a bit more infrastructure in that edge environment, you could then utilize the E1S network packet broker. Just real key features from here: third-party support, synthetic monitoring, meaning we can generate traffic, and we can develop or generate net flow data so that you could compress data. Say if you need to send data between data centers, or let's say on-prem to off-prem, because data on off-prem is very expensive. So NetFlow is a way of taking packet data and crunching it down to about 3%, giving you some, it's like almost like a log syntax. As you can see here, if you have a very, very large topology, many sites of large amounts of data, you would use these E1Ss to collect data and then pass it directly to the Vision 1 via a GRE tunnel. In this concept, you would just be sending the entire packet. From there, the Vision 1 is another packet broker. We can talk about it on another webinar sometime. A lot of great features for making the traffic the most efficient for all the tools, IDS, well, I want to say all your out-of-band tools, performance monitoring, for security monitoring, and your visibility topology. And then once again, if you didn't need the entire packet, you could generate the net flow from these locations and get that to some of your favorite net flow collectors or Splunk or things like that. Even Security Onion, I think, will handle that. Okay, so I'm going to switch over now to my browser and give a little Hawkeye demo. One moment. Apostles, can you give me a quick okay? You see the Hawkeye platform?
Yes.
Thank you very much, sir. Okay, so here is my Hawkeye platform. As you see, we always start out with the dashboard. The dashboard is the end results of after I've done all my configuration, or more or less created all the tests I need to be conducted from certain locations. Now, this is a demo environment. There's only a few probes. As you see from the top, I got 3 probes available. And I just, in preparation for this exercise, I started doing more and more testing, as you'll see, across the 6th of June in comparison to the 5th of June. And on the 7th of June, we see all our tests starting up now. I can see how many tests failed and passed, all those good information. I can see that, or I can bring it into you a little bit more. Right now, I am currently sitting over here in Germany, in Mainz, Germany, and the lab that I'm hosting all this information in is inside of Bucharest, where I have a lot of nice equipment. Excuse me. Okay, so before we get started with the, well, first we'll get started with the configuration points. So, of course, everything is going to start with probes. Probes are launched, there's a Windows executable to launch it on your Windows machines. Your other devices will typically have maybe 3 or 4 lines you'll need to put in. What is the IP address or name of the Hawkeye server, and what do you want to call me? So you know how to, organize it when it gets to your dashboard. From there, the probe will just populate into this probes area. Excuse me. So we're going to have the probe name, the IP addresses available to that probe, so I can conduct tests between that probe. Excuse me. And in some cases, you might have extra IP addresses available, depending on, say, you have, public and private exit points or endpoints available on that machine. So once I have my probes, I'm going to go into test execution. So from this, we have node to node and real service. These are the only 2 we think about right now. So node to node, as I said, this is your 2-arm test. We're going to have 2 endpoints. From this, we're going to select, or excuse me, I'll load up. Okay, so from here, you see the dashboard of the test I currently have configured. Some quick information about it. We can see the interval, like how often I'm conducting these tests. So we have one that's going, this voice bidirectional call that's going every 3 minutes, and this network KPI known points of inspection, speed bidirectional test. As you see, one's going to be running and queuing, and this is a continual process that you're going to configure from the bottom here by creating specific tests. So I have probe from, probe to. So this GJ guy is actually my desktop, my laptop sitting here next to me. So I can have a test that's going to go between this laptop and my solution lab. And the test type, I would select from here. And for example, I could do multicast video over RTP. I'm not conducting this right now. So we could select a multicast address. This could be, interesting, or I want to say related to your personal environment a little bit more. And I actually did this type of test one time. I was at a convention, and I wanted to do some video recording. And I had these 3 Raspberry Pis, and I was recording with VLC, and VLC is very, very manual in getting that set up correctly to do configurations. And I needed to really understand how much bit rate I could travel across the Wi-Fi network while keeping my keeping my video clean. I didn't want to have frame skips or, distortion or stuff like this. So I could set specific bit rates and test across different bit rates. So I could actually do a one-shot test. So a one-shot meaning I'm going to have no minutes of frequency. So I'll just go ahead and shoot this one. You'll see that it'll be populated to my test list into the queue. And then say, for example, I could go ahead and just queue up another one, set this to 2. And queue that next one. And we'll just let that go. So from now, we're going to run to our real service tests. Okay, so once again, it's very much the same screen, but a little bit different information that will be available now. Mostly on the types of tests you'll be able to conduct. So from here, we'll have the tests such as Skype, port scan, path discovery, Microsoft Office 365, YouTube, things like that. And so from here, you'll see that we're testing all of these endpoints on a 5-minute interval. In thus, I could get an idea of, okay, well, during the daytime, how is services at my branch office that's running across the VPN to my primary data center, because that's where I have the firewall that's leading out to the public internet that I'm going to allow them to cross. Now you got to have a couple of hops involved in this. Is the service still usable during that type of process? Is it still usable during the entire day? Is there certain times of a day that we're going to experience certain delay or loss from the network aspect, resulting in poor performance on the user's aspect, and that ends up coming out as phone calls saying, "Hey, why is the network crap?" Right? And then what's convenient about now is like, well, I see on the reports at this certain time, it looks like that OfficeLive.com is having some issues. But yesterday it started to clear up at about 3 o'clock. Let's just see what happens then. It might be a problem with the service provider. Now, that's a very different support call. If you've ever been on one, they can be terrible. It's usually pain, anger, and frustration. And if you have a solution to provide to them on the spot, or at least the next step, they can start to calm that nerve and that frustration down a bit. So going to our dashboards, I'm going to first go to our outliers, go quickly through this. I'm going to need to get to Threat Simulator very soon. Okay, so from here, I have my outliers dashboard. So this is looking for specific tests that had a variation in what's normal or expected to be normal for that network path. So this path being from the solution lab in Bucharest to my desktop, we had 21 outliers, and right now it's at about a 1% ratio. So from here, I can drill into the specific times or the specific types of metrics I want to look at to understand what's happening. So from this, what's quite interesting, you see them have some of this testing that's going on all day, and then at 10 o'clock, or actually about 5 or 10 minutes till 10 o'clock, we start to see a degradation in performance. Now, it could quite be possible that since I'm on a video call streaming all this information to the WebEx right now, that I'm actually creating too much load across my PC to handle this extra stuff. So this now correlates quite easily to what's actually happening on the network performance side and what we're seeing from our testing environment. And then lastly, I'm going to just go to report creation, just so I can move on to Threat Simulator. So at the end of the day, as we said, we want to get this information to us and make it easily presentable. But also, what I would say is you want this information to be easily presentable to your boss or your boss's boss. So you can get this presentation down. Hopefully, I didn't click save and schedule. 1 second. There it goes. So you could get these reports that'll be generated for you. They can come down in PDF or HTML. You can put them on web pages. You can send them in emails and that type of idea, where you can start to drill down into specific sites, information, or trends across certain periods of time. You could focus on metrics of specific types of tests so that you could see just how voice calls are doing between all the various paths. And let's see if I find a bit more complicated graph. There's a few more complicated ones. Round trip time. I don't really have a very nice graph right here from these tests. Either way, you could do it for certain metric trends across a period of time, as I said, or I was also saying before, we can get a site trend report, for example. So you would get a more of a crunch into the endpoints, which can be identified as a specific site or location. So as we see, we have for my computer starting from this point, it'll come out as PDF, so all the links will be very easy to use when it comes to reporting time. Okay, so I'm going to go ahead and stop here and start moving into Threat Simulator. 1 moment. Okay, sharing content. And okay. Okay, Apostolos, can you see me again?
Not yet.
Thank you very much.
We can see you.
Thank you. Okay. Okay, so we've just been talking about network performance monitoring, about having a tool that'll use endpoints, that'll work in an automated fashion for you to do network testing, such as making phone calls for you or pulling YouTube videos. Well, on the other side of that, Ixia, I talked about it had the 50 or 20 years of test experience in the network focused area. Actually, I think I forgot to mention, we also have the security testing area, which we have 15 years of experience in, starting with our Breaking Point platform, and hopefully you've heard of that already. So Keysight's Threat Simulator. And we don't need to go through these intro slides real quick. Let me just pass by this. Okay, here we go. Keysight's Threat Simulator is a breach and attack simulation product that safely simulates real attacks in an automated, continuous manner that provides remediations and actionable intelligence. Big, long definition. So first, we'll look at breach and attack simulation. This is a new market, a new idea of how to, let's say, deploy, security testing in environments. So it's going to be a much more realistic type of attack. Hopefully it won't just be packet captures that'll be sent from place to place. Hopefully it'll be tests that'll be conducted in a proper audit, or that'll follow the cyber kill chain so that it looks the most realistic to the network. As this is what we're actually looking to test for, is the realism of how a lot of these machine learning models react. Not when you give a sudden burst of packet capture information into that environment. It'll always create an outlier. So with that, it's going to be automated, and it's going to test in a continuous manner. Just like you saw with Hawkeye, this is also going to be testing now on the security aspect. Is my security configuration okay and safe from, for example, the WannaCry infection? And how do I know that? Well, we're going to continually send this test through to verify, does your firewall block it? And we'll do it every hour of the day or every day so that you have a reassurance that you are safe. From that, if a test were to fail, we can provide remediations and information about that CV. For example, we can give you the information that comes directly from MITRE, as well as give you packet captures so that you could grab the files and create signatures on your devices yourself. With our tech partnerships with a lot of different vendors that reside in the firewall and the IPS business, we've created a lot of special integrations. So if you have a specific Cisco web application firewall and you were to fail this specific attack, we're going to send you to where the specific configuration to fix it is. And you'll have all the information provided to you from then Cisco. So this market's growing, and I still wanted to talk about this side. Maybe you might not be interested about the market, but on the left side is what this market is addressing. It's addressing gaps in your coverage. Can I withstand a specific type of attack? Are there misconfigurations in my tools? Do I have overlapping tool coverage? Do I have ways to fix the problems? And how can I, how can I find these issues? In a lot of cases, I might be only able to find these issues when I can hire penetration testers in January. And then, maybe I'll have a red team or my security team make a run of the environment half a year or something of that nature. And we never know how long the breach was actually there if you found it in July. You only know that, well, we thought it was covered or cleared in January. Thank goodness we didn't get attacked during this time. But you really have no understanding of what caused that breach to open up. So going back to Keysight or this Ixia technology coming into this application threat intelligence platform, this has been built for 15, almost 20 years now, and is being used all across the platforms from let's say the legacy Ixia, now Keysight NSS test and visibility concepts. So as I said before, the testing started in 1997, and they acquired Breaking Point in 2005. Now, this is when they opened the application threat intelligence platform, and they created this team of security engineers who are there building threat intelligence. So this means they spend all day scouring the public forums for new bugs or new problems that come out so that we can build a map of that problem and then test with it so that we can make sure that the firewalls at the firewall vendors, because one of our primary candidates for all of this is the equipment manufacturers, the network equipment manufacturers, the firewall equipment manufacturers. They will buy this just to make sure they can get completely clear of all the variations of types of attacks we can think of. So we're partnered with the top NIMs, network equipment manufacturers, carriers, governments, and enterprise. They trust our test software and methodology and hardware. So that's, I would say, useful or like a good confidence to bring into the environment if you would like to look into these products. So as I said before, this is not new intelligence for us. This isn't something we just started recently. This has been done for 15 years. It's been spread out across all the platforms. So as I told you, we took those signatures, we learned how to rebuild them and send them out. And then we figured, well, if we have a network visibility platform, we can at least give you some intelligence on if we see certain things that we recognize. So not only are we testing in the environment, but we give customers some insight on applications and malware that will go through their network to further enable their security tools to bring insights to the teams so that they can do their job better. With that, you'll have things like Threat Armor, which is kind of positioned with Threat Simulator. And that Threat Armor is a turnkey solution that you would sit in front of the firewall that says, well, I don't want to spend all day or making these firewall changes or beefing up or doing hours and hours and hours of research on all the things I need to do. I will simply put this box in front of my firewall and it should block everything that is known bad. Therefore, the only configurations you really need to focus on your firewall are very, very particular topics, and thus a lot of load gets dropped off that firewall. What's convenient about that is that, well, while we were using Breaking Point and we were testing firewalls, Breaking Point's very, very, very good at generating random traffic and then sliding attacks in. So the very random traffic created a new situation on our firewalls that we didn't expect. And well, we found that, engineering teams, when they're testing and benchmarking things, sometimes they bias their tests in certain ways. So say if I was going to test with a YouTube video, I would use the same YouTube video and caching would get involved, or I'd use specific byte or packet sizes to get certain performance marks. In reality, we find that in some cases, your 1 gigabit firewall after about 300 megabits is not going to be able to properly secure you in specific configurations. So the idea being is that we'll use something like Threat Armor to sit in front, go ahead and knock out everything we can so that we can reduce that load on your firewall, and it can just focus on the most important stuff that would get by the most well-known attacks. So going more into this threat intelligence, for example, the WannaCry infection, I'm going to speak about this a few times as it's just a really nice story that a lot of people know about. So around March, Microsoft released the patch that's saying, hey, we had this critical problem. And then on the 14th of April, with Shadow Brokers released this Eternal Blue and Double Pulsar exploit. And then on April 25th, we had already, from our application threat intelligence team, the ATI coverage, we've already included that into Breaking Point for testing so that, our customers and clients could test and make sure they would be safe from this WannaCry. And then sure enough, within a few more weeks, the WannaCry attacks start to hit the world. And this is exactly what we're trying to stop. What we're doing with Threat Simulator is allowing easier, smaller bite-sized access to these specific types of attacks that can be updated as we get new information or new types of attacks. For example, I'll show you in our demo, we already have a COVID-19 mail spam attack, so that you can always have the most updated, most important attacks checked and verified so that that one day doesn't happen where that gotcha came in. So a little bit of history on this, and if you've been in the market for a while, you kind of start to relate to this. In the 90s going into 2000s, we had the prevention era. You had firewalls that were supposed to be built in a certain way and you were supposed to be protected, and it didn't work. So then we got into building out-of-band IDSs, detection, more information, more visibility, and it still wasn't working. We go into 2010, 2019, we get into SecOps. Now we are ingesting all the logs, all the packets. We're looking at everything all the time because we still can't stop attacks. It's still happening. And what's even more interesting, we're not stopping attacks from humans anymore. We're stopping attacks from robots that people have coded. So now, just like we have, agents that can run around and act to test our network and verify our security, hackers have agents that run around and attack your network and find ways to exploit your network. And guess what? They can sleep easy while this is going on, because this can go on for an entire year, waiting for one hole to open up or one exploit to be found, and then they've had their day with you. So the question is, am I just throwing my money away? How can I ensure that I am protected? Because what happens when you do get fined is it's going to be a lot of money that's going to go away. And then there's going to be the questions, well, why didn't we see this coming? I thought we went through all the normal things to make sure we were secure. We did hire a penetration tested team at the beginning of the year. We even had a red team come in at this point at sometime later in the year. What can we do better? And this is more of where we're trying to come in to give this breach and attack simulation market some nice software. So focusing first on the breaches. As you'll see here, outside of emerging threats or malware, so new problems that come, actually, you can even consider this. Every one of these issues are related to the human. I call these layer 8 issues. There's 7 layers of the OSI. The layer 8's the human, because quite often the human will give you bad information. He'll do things incorrectly, and these things don't always get covered up or observed or fixed immediately. So security tools misconfiguration, it may not be on purpose, but there could be a bad configuration that might not protect you completely. There could be a temporary policies change. Oh, COVID-19 happened. We need VPNs everywhere, but we also want to have good performance. Let's implement split tunnels so that now I could have all my home users go directly to their own internet before they come to the office, because, man, we didn't really invest in VPN technology. And now you have an entry point for WannaCry to get into their laptop, cross the VPN into your data center and attack. Motivated attackers, bad user behaviors, insider threats. These are all humans creating issues. The emerging threats, you could even say this could be humans on the fact of there was a developer who may have not done something correctly, and this exploit was sitting there waiting to be had, right? So from there, what are the common type of assessments we've been doing, and where will the breach and attack simulation come in? So on the left side, we see frequency of validations on the y-axis. So this is how often I'm going to be conducting these tests. So a vulnerability assessment will be like a port scanner, not a geo scanner. I'm just going to open, 60,000 telnet sessions to every port that you have available so that I can see what's available, and I'll just give you some insight on it. Well, if I see this open, it might be something related to this you might need to be concerned with, but it's not always very detailed. It's not going to actually create attacks or see how your firewall or your IPS is going to react under that type of attack. So on the bottom side, we have completeness. So on the far right, or the x-axis on the far right, you'll see our pre-deployment security testing. So I had my penetration team, or actually this is a sandboxing, even before the penetration team. So this is, I haven't even built the network. This is generally where you would buy a breaking point. Okay, I'm about to build everything. I need to make sure this guy is going to be completely ready to support my business for years to come. And so we're going to test it against everything that's known. But this is done in a sandbox lab. It will never be done in a production environment. After this is done the first time, equipment will literally need to come out of the rack and move to another location for it to be done again. And this is why we bring in penetration teams. So they'll be a bit more focused on how to hack in and test security on production networks, and not so much in the lab, for example. So with that, our breach and attack simulation is in the top right, as it's continuous, it's automated, it's comprehensive and safe, meaning it's continuous, so it has the top end of the y-axis. because it is an automated test that will be conducted, for example, on an hourly or daily basis. With that, its completeness is there because it is actually sending real attacks. They are the real signatures of these attacks, so your firewall should block it. Your IPS should recognize it. And in this way, we'll also follow the kill chain because, first there'll be an attack that goes to your internal network. And in a lot of cases, the guy that's been hacked, the server or the PC that's been hacked on the internal, will then have to go back out to the internet to grab more stuff. So we're going to go through that type of exercise with our agents so that you have the complete realistic attack being conducted on your network, and you'll see how it will continue. So the question is, how do you measure your security posture on a day-to-day basis? Are you secure? How do you know that? And if you don't test it, if you don't measure it, you can't prove it. It's always been the case in networking for quite some time now. And with security, now we're creating a new style of metrics almost. So with that, we want to do these tests continuously, because as we said before, most of the issues that are arising at times when we're not looking, or arising from people that are hiding their mistakes, or too shameful to admit, whatever the case may be. So now I'm going to switch over to the threat simulator. Give me one moment. Okay, Apostolos, one more time, please.
Yes, it's visible.
Thank you.
Good done.
Okay. So here we have Keysight's Threat Simulator. So the operation will be conducted completely from this left ribbon, much like you saw with the HawkEye platform. So as you see here, I'll have two primary components: the agents and then the dark cloud. The dark cloud is a set of agents and stuff that will operate as malicious hosts, malicious DNS servers, malicious anything out in the web to create that realistic attack scenario. From there, you would have your agents that will be deployed in different offices or different security zones inside the same offices. So for example, if I have my DMZ, I could have my data center and DMZ actually quite close to each other. What this little circle right here represents is the equipment that is in between these two agents. So I see I have a point between the two agents. I have a point between my agent and the dark cloud. I'll go into this. This is called a security profile, and I'll go into this a little bit more detail in a moment. But generally what this allows me to do is to conduct certain tests, say in the WannaCry, from the dark cloud to the data center. And if the data center was infected, I could now see, will the lateral movement from data center to DMZ occur? Will that test be successful? Because then in the idea of security, this DMZ was now compromised, and now potentially it could create a leak to my branch. So going back to let's say like the full walkthrough, we're going to start at the deployment phase. So at first we have very, very easy, almost automated instructions for how to deploy agents, say on AWS. So we have the YAML file templates available for you, and very easy on the on-prem. If you have a virtual box instance or VMware, you can spin up a Linux based VM. We need to use Linux VM because we need Linux containers. Right now, we're seeing a little bit of performance issue with Windows containers. So for now, we're just using these Linux containers. You would then follow these copy and paste instructions to get this agent installed and running. So after you copy and paste each one of these items, going through this list, you will have an agent prepared in probably 7 minutes. And it'll download Docker, it'll download the images, it'll run the images, and you'll just have to name it at the end of the day. So after you would install your agents, they would populate the topology. Just so you can see, the agents will have these specific tags, location. It'll tell you some information about the IP addresses that'll be used. for the testing. So that this is the only information that'll go up to the management platform. There's nothing else from your environment going up for this. So from there, we'll move into assessments. Assessments is the library of the types of tests that we can conduct. So for right now, we have some variation of policy, instrumentation, and kill chain. So for example, policy could relate to URL filtering, and let's just go right here. So what we're looking at with URL filtering is how the employee is reacting on the network. So let's go back to the example. COVID hit. I need to have VPNs. I have terrible performance, so I'm going to use split tunneling. And in this case, I could verify if let's say a user could reach out to specific locations, hacking, gambling, pornography, these locations, and successfully get information back. So the idea being the test would be conducted in 2 audits. So how this works, you'll see the beginning of the line will describe where the test initiates. So it's initiating from an internal user. We're acting as a employee at this point in time. And I'm going to try to go out to the dark cloud to get to this malicious site, which will act as the pornography or the hacking location. The intent is that the security control should stop it with something like a web content filter. If it does go through, it means it was allowed. It should be a policy, a violation, and we should get this looked at. So something a little more interesting and realistic. We'll go to the kill chain area, and we'll talk about the WannaCry infection. So also, what was very convenient for me with this product, as I mentioned earlier, I come from satellite communications, field operations, network operations center. I've done a lot of operations. I've done a lot of troubleshooting. I've worked a little bit on firewalls in an operational sense, but I was never a penetration tester. And this is also why I'm believing the market's going to grow in this area, is because generally a lot of businesses, we won't say most, a lot of businesses don't have a team of penetration testers and security guys that are just readily available with how to hack your boxes. You do have guys that can fix firewall rules and get your network in order and help you get through the dark times. But this is where this tool can really come out and shine for you, because it's an educational piece, and it's been a very educational piece for me. Before I saw this product, I didn't know what an external blue exploit was and what a fuzz bunch backdoor was. The whole point is that now I get to understand from a testing point. So right here, I have 7 different numbers, meaning I have 7 tests that are going to be conducted to go through the entire kill chain. So I have a nice text details about how that test is being conducted. And now I'll go back to my ladder and I can get more information. So once again, my first test will come from the dark cloud. I'm going to try and send this external blue exploit into the internal one target. If it was able to get to it, I'm just going to assume it was able to install. In that point, the next test is the installation of the WannaCry DLL. So once again, starting from our dark cloud, we're going to send it all the way into our internal one. If it was able to get through, we can imagine the DLL was installed and we now have execution. Now here we can go into the command and control phase. So now we're going to try to do a DNS query out, and the expectation we get our response, and the next step would be the hard drive would be encrypted. So maybe while this test was being conducted, when this DNS query was conducted, your firewall was able to stop this. At this point in time, we would stop testing on all of the rest of these tests, because in the WannaCry cyber kill chain, you were able to block at audit 3 of the DNS query segment, of the command and control segment. So from this point, at least up to this point, you are safe. That is what we're trying to prove to you here. So we take our assessments, we decide what we want, and then we build scenarios. Scenarios will be the combination of agents and an assessment. So real quickly again, just so you can see some of the nice, I would say the graphical information that comes out. Once again, we'll look at the WannaCry infection. So as you see, we're going to color code each of the tests as it's going to be done in numerical order with the cyber kill chain information applied to it. So we know the first one's exploitation. The second one, that's installation. The third one's command and control. As we go on, we go on, we go on. So real quickly, I'll add in agents, and in some examples, I could change ports if that was required for specific services that relate to my environment. And then I would, start and run this test. As I have already a whole bunch of WannaCry tests created, I will not create another one. Generally, after you create or build the test, you'll be brought back to this page where you're going to have these various actions. So I can run the test now, or I can look at some of the details that have come from these tests as they've been occurring. And as you see here, I can see the last time it was ran and when it's scheduled to run again. So you have a scheduler to ensure or to have a continual check to verify here on a daily basis at 4 o'clock every day that we can withstand a WannaCry infection. And I'm sure of it. Why? Because I sent one in. It's actually quite nice at the end of the day when you're always concerned about the GDPR or some bad day that you're going to get fined for $500,000 or euros, excuse me. So from here, you'll create your tests. You can have a nice dashboard, or you have a nice layout for it. Go into specific details. So say we'll go into the scenario results. Actually, we'll start at summary just to go from the top. So now we are at the dashboard. So at the end of the day, for you, it becomes a single pane of glass of security intelligence that's going to give you a prevention score, or how well you've been able to protect yourself over the period of time from these variations of attacks. So you can see which specific types of scenarios are failing the most, if there's specific types of assessments or specific agents. And you get this nice score card at the end of the day that can kind of give you an idea of how well you're scoring, because ideally in the long term, you should have multiple tests, 20, 30, 40, 50 tests running every week, just to make sure that everything is in order, and you will know for certain that it is with these results. So from here, we can go now to assessments results. Once again, I may have created a WannaCry infection, but I created 4 or 5 variations of it, going, say, from the dark cloud to my DC, and then the dark cloud to my DMZ. And from here, I can see how much I was protected in each one. So as you'll see here, let me have a little bit of lag. There it goes. Okay, come on, work with me. I think my computer's not liking the fact I still have HawkEye tests running on it. So either way, as you see here, we have a test between the dark cloud and my branch office. So going from the exploitation phase, I sent in the external blue exploit. This was allowed, meaning I failed to block this test. So I'm going to continue through each one of these tests. I got through installation, command and control. I was getting to the point that I was about to go from the branch to my DMZ, and then this was blocked. So on the point of let's say exploitation and looking at the details and the PCAP information or remediation information that'll be involved with this. So this is a focus of this specific audit, so we're not going to have too much information here. What I do want to show you is this recommendations area. Okay, so earlier when we first started talking about Threat Simulator, I mentioned a security profile, or the devices that are going to sit between my 2 agents. So if you look in the top left, I have dark cloud, and then I have my list of devices that's in between that dark cloud and this branch agent here. So for example, if I select this, I can start to create a security profile, or all the devices that this traffic must go through to provide me the exact remediation information I need to fix this issue. So for example, I can select various types of vendors, Checkpoint, Fortinet, IBM, Palo Alto, Snort. To the whole point is it's actually a test. So we actually have a measuring point. The measuring type is a signature or such as a firewall rule, because we're sending an attack to test does this rule work, or are you missing this rule to block it? Okay, I'll close this. So since I know what test I'm sending and I know which devices I have between this, I can get specific recommendations for specific devices. So say for my firewall rule, it's recommending I block SMB version 1 traffic globally from and to the internet. You could get the CV information, the attack tactic information. Once again, this is very educational for your operational guys or girls. Once they get into this, they can get to all the resources necessary to thoroughly understand what this is. They will level up going through this product and just building it, fixing their problems first by getting to all the resources necessary, and then having a system that's automated and testing to validate that, you know, your posture, your security posture is always healthy. You'll always be secure from at least these most important attacks. Come on, UI. There we go. So from the assessments results, we'll look at scenarios a little bit more. I just want to show one more kind of neat component before we break or get into some questions. So as you see here, we have the variations of prevention scores, and some seem to be good. Here's one that's 55%. Actually, let's go for, let's try something a little more. Let's try this data exfiltration. That looks like an interesting one. Okie dokie. Oh, excuse me, that was just once. Let me bring up another one. I was hoping that'd go a little bit faster. Come on, close out. All right, let's just try this one. Oh, there we go. Okay. So this history diagram here is actually quite important in my eyes. In the aspect of, we've already started to see certain variations in companies and their firewalls, especially in the public cloud infrastructure. These firewalls and most of these platforms that'll auto update their threat intelligence and signature profiles and things like that. And now you see these are tests that are being conducted on a daily basis. They're the same exact tests, and they should generally be done with the same hardware and the same configurations. And we have found that on certain days, maybe there'll be 2 or 3 days, that there'll be an extra attack or two that's able to get through, because upon of a certain security update or a signature profile update that's been sent by that vendor, we have a change in the result. So, and this also gets fixed on the back end. We've seen it times where we'll have a mostly protected state. It'll go into a less protective state. And then magically after, next week, after development teams got back to it and fixed the problem, we were back into this better situation. So it's interesting to see not only from your own side, your own configuration changes, but also threat intelligence updates that could be coming from the vendors and the products that you also choose yourself. Okay. So, yeah, I think that's, I think we're good here. Apostolos, I think we can go ahead and start to bring this to a close. Thank you everybody for listening. I'm not sure if we're going to do a Q&A now.
Thank you, John. There is one question in the chat from Nikos. So there are three kind of items in his questions. For example, how can organizations A, detect and avoid negative asymmetries, B, discover and exploit positive valuable asymmetries, and C, innovate real-time or near real-time in both business and military context? Thanks. This is the question from Nikos.
Yes, yeah. I'm reading it into the chat now.
All right.
So, terminology is real fun at sometimes. So, discover and exploit. So, let's say so negative asymmetry. So, we're seeing differences between two points of configuration, I'm assuming. Okay, well, so let's start with the C. So, real time. Everything in these tests are real time. It's all, even while you're conducting a test from the threat simulator aspect. I can even demonstrate this real quickly. I actually need to go to scenarios. And let's see, I'll try another demo web app right here. Oh, we'll try this one right here. It's Myria infection. There's not much there. Initialize, and I can go ahead and view scenario results. Just give it a moment to get started. So on the other questions though, so let's see. Discover, so as far as like discovery, there's not going to be much, there's not going to be any discovery from the threat simulator aspect. So threat simulator is still needs to be looked upon as like a testing tool to verify the network detection and response tools. So your firewalls, your IPSs, we're integrating now with IDSs and things like that. So for example, we also have, and I was glad that we had this extra moment, we have also an integration with SIEM environments. Right now, we only have the QRadar and Splunk as far as integrations. I am myself actually working on Elasticsearch integration so that we can open up integration to Security Onion and things like that. So just to kind of go into the real-time, like say, experience of this, whenever the threat simulator is about to conduct an audit, conduct a test, it's going to send a message to your SIEM to say, hey, SIEM, or hey, SOC team, I'm about to send a test. Don't worry when your IPS sends an alarm out for the WannaCry infection. And with that, after it's sent that message, it'll conduct the test. Once the test has gone through, it's going to send a new query to verify that your firewall or your IPS did in fact audit that test. So it's very convenient for your SecOps team to keep in track and align on what's happening with these planned attacks and against the normal attacks that will be coming in. Outside of that, I'd really like to take that question offline, Nikos, and further understand what you mean by these asymmetric. It's been about 15 years since I've been in the military, and I remember this type of terminology. It's not so common everywhere else. But I did a lot, or actually what I would love to see myself. So I worked very, very heavily on tactical satellite communications, and the fact that we spent all day building IPsec tunnels from our data center to little tactical trucks that are all over the place, 20 or 30 of them. And we'd spend building tunnel. Once we get the tunnel up, we make a phone call. We ask them to pull a YouTube video and pull an email. And if they're able to do all that, okay, good. And we hang up the phone. And this is where it's for me, and a lot of times you get some of this layer 8 problem information. And actually, I even created my own phrase, never trust Joe. Never trust Joe, because Joe might not always know what he's talking about. He might give you something very, very incorrect, and it'll totally curb your troubleshooting. So to me, it was always nice in the idea if I could just get the information directly from the machines to understand the problem. So you know, the idea in the military aspect, you could have a Hawkeye endpoint sitting on a satellite truck. So whenever they bring up their comms, immediately these tests will start occurring and start populating in your dashboard. You'll have that graphical user interface as well. So you can see the shots, see the tests as they're pinging between each one. There's a lot of nice graphical points to it. It's heavily used in Japan, actually, to better improve your experience with these products. But yeah, Nikos, I'd really like to go into that further with you, maybe outside with the Odyssey team, or maybe the Odyssey team could help fulfill this, get them more information on this question. And we can cover that later.
Thank you, John. I don't know if the audience has any other questions. In any case, you can reach your Odyssey designated contact and inquiry on anything you saw today in this webinar. And we're very pleased with Keysight to have a very specific discussion with you, or a on purpose presentation on a specific item.